Hello engineers, welcome back. In this video, we're going to study a new topic, which is a very interesting topic called topological sort. Okay, I hope you're ready. Let's get started. So in this video, we'll see the concept of directed acyclic graph, which is also called as DAG in general. And then we will see how to apply or how to derive a topological sort order from a graph. So let's see what these terms mean. So a DAG is a directed acyclic graph. So if you look at the terminology, firstly, it is a graph for sure, and then it is both directed and acyclic. So what is the meaning of directed? Directed means when there is an edge, edges have direction. Edges have direction. And acyclic means paths are not cyclic. So what is a cycle? Cycle means if I start down a path in a graph and if I reach the same vertex again, then there is a cycle in the graph. So if I keep going down this path, I will be in an infinite loop, right? So this graph is acyclic, meaning in the entire graph, there should not be a cycle anywhere. So that is the meaning of acyclic. So directed means edges have direction, which means I know if I go down one path, I know which way to go. It is a single directed graph, right? It's not a bidirectional graph where the edges work both ways. So edges are always one-sided. Okay, so there is a direction. And acyclic means no path in the entire graph will be a cycle. Okay, so let's understand this with this example. So let's say this is my entire study syllabus and I need to study all these subjects: math, algebra, physics, and chemistry, right? But in order to study all this, there is some predefined order, or there is some dependency, or there are some prerequisites I need to do before I reach or before I start studying a new subject. Okay, let's see how it goes. So there is basic mathematics, which does not have any dependency. And then there is algebra 1. But to study algebra 1, I need to understand basic math first. Okay. Similarly, to study geometry, I need to understand basic math. Okay. And to study algebra 2, I need to study algebra 1, which in turn requires that I need to study basic math. So algebra 2 has a dependency on both algebra 1 and basic math. Physics, on the other hand, requires that I study algebra 1 and basic math. Same thing. Same goes for chemistry. So all these three subjects require algebra 1, which in turns require basic math, right? And then look at this advanced physics. Advanced physics requires that I need to study physics first, but I also need to study algebra 2 first. Only if I study these two, I will be able to study advanced physics, okay? And to study algebra 2, I need algebra 1, and to study algebra 1, I need basic math. To study physics, I need algebra 1, and to study algebra 1, I need basic math, and so on, right? And when I want to study pre-calculus, I need to learn algebra 2, which in turns require algebra 1 and then basic math. And to study calculus, I require pre-calculus, which is dependent on algebra 2, which is in turn dependent on algebra 1, and that is dependent on basic math. So there is some kind of a dependency, and if you can see, there is some kind of a given order in which this study needs to happen, right? So this kind of graph is an example of a DAG. See, there is always a clear direction in the graph. We know the path forward, and there are no cycles in the graph. There is no edge that is pointing backwards to any other vertex which will cause a cycle in the graph. So this is a good example of a directed acyclic graph, right? Now let's see what is the meaning of topological sort. So in this entire graph, we have all these dependencies, right? But as a student, in which order should I study? Should I study chemistry first? Should I study physics first? Should I study math first? After math, what should I study? Should I start with geometry? Should I start with algebra? There should be some kind of sequence, right? Because I can only study one thing at a time. So the order in which I need to study, that is called a topological sorted order. Topological order, or we can call it a linear order, in which I need to start preparing so that I can complete all these while taking care of all the dependencies, right? So like if I want to study physics, I first need to complete algebra 1, only then I can start studying physics, right? So to create this kind of order, we have an algorithm which is called topological sort. It can be implemented using both depth first traversal and breadth first traversal. In this video, we will study about depth first traversal. Okay, so let's see how that looks like. So now let's begin our topological sort algorithm. So for that, I have created an adjacency list here. So this is the representation of this entire graph in an adjacency list format, right? For example, 0 is basic math, and from basic math there are two nodes coming out, algebra 1 and geometry. And from algebra 1 there are three nodes coming out, three edges coming out, algebra 2, physics and chemistry. So I have added them here. From geometry there is no edge coming out, so this is empty. From algebra 2 there are two edges coming out, pre-calculus and advanced physics. From pre-calculus there is calculus. From calculus there is no edge. From physics there is no edge. From chemistry there is no edge. From advanced physics there is no edge. So this is the adjacency list representation of this DAG, of this directed acyclic graph. Okay. Now my intention is to create an order as an output that will help me understand the order in which I need to study all these subjects, right? So this is how the algorithm goes. So for this, we will take a stack which is empty, and then we will keep a visited array in which everything is false to begin with. I've just kept it as empty for now, and I'll fill it with true as we keep visiting those vertices, right? So let's begin. So we are going to use depth first traversal for this. So we start at 0, which is basic math, and we mark it as visited. So basic math is visited. Once it is visited, we will start exploring edges of basic math, and we will go down deep into the graph. So we'll start at A1. So when we go to A1, we will mark A1 as visited, and we will start exploring the edges of A1. And then the first edge is A2. So we go to A2, we mark A2 as visited, and we see the edges of A2. First we have PC, which is pre-calculus. We go to pre-calculus, and then we mark pre-calculus as visited. And then we go to the edges of pre-calculus. So this is calculus. So we go to the calculus vertex, and then we mark calculus as visited. And then we have finally reached an empty spot. So from here we start returning, right? So when we start returning, when we have completely exhausted the exploration of a vertex, that is when we will add it to the stack. So we will add calculus to our stack. Okay, so we are done. Now we are returning. So after calculus there is nobody else, so from here we will return as well. So we will return from pre-calculus. So from where did we come to pre-calculus? We came from A2, algebra 2. So in algebra 2, is there anything else? Yes, there is advanced physics. So we go to advanced physics and mark it as visited. So from advanced physics, there is nobody else. So we start returning. So while returning, we will add it to the stack, advanced physics. As from where did we come to advanced physics? We came from A2. So in A2, is there anything left? So there is nothing left. So we will start returning from A2. So while returning, we will add it to the stack. Okay. And where did we come to A2 from? We came from A1. Is there anything else left in A1? Yes, there is physics. So we go to physics and mark it as visited. And there is no edge to explore in physics. So we start returning from here. So before returning, we will add it to the stack. Okay. So from where did we come to physics? We came from A1. So is there anything left from A1? Yes, there is chemistry left. So we go to chemistry, we mark chemistry as visited. And there is no edge left to explore in chemistry. So we start returning from here, but before returning, we will add it to the stack. Okay, from where did we come to chemistry? We came from A1. Is there anything left in A1 to explore? No. So we start returning from A1, but before returning, we will add A1 to the stack, algebra 1. From where did we come to A1? We came from basic math. Is there anything left in basic math? Yes, there is geometry. So we go to geometry and mark it as visited. This is done. And then from here, there is nothing left to explore, so we return. So while returning, we will add it to the stack. From where did we come to geometry? We came from BM, basic math. Is there anything left to explore in basic math? Nothing left. So we will start returning from basic math, and before returning, we will add it to the stack. And that's it. That is the end of our exploration. So this is simple depth first traversal. At the end of each exploration, we are just adding it to the stack. That's all. That is the only change we did from our depth first traversal discussion to this sorting discussion. So we have a stack. So we go down the graph. Once we reach the edge, once we explore all the vertices in that vertex, we just add it to the stack. Okay. Now our stack is ready. All we need to do is pop everything from the stack, and then we'll see how it looks like. So we start popping out one at a time, and that will give us our final output. So let's see. First we pop basic math. After that we pop geometry. After that we pop algebra 1. Then chemistry. Then physics. Then algebra 2. And then advanced physics. And then pre-calculus. And then calculus. Let's see if this order is making sense. First, we are studying basic math. Then we are studying geometry. We come back. And then we study algebra 1. And then we start studying chemistry. And then we study physics. And then we study algebra 2. And then we study advanced physics. And then we study pre-calculus. And then we study calculus. So we have found a beautiful order in which we can study all these subjects. And this order is our topological sorted order. Okay, if we study in this order, we can successfully complete all of these. Okay, so this is a very good example of a topological sort. So this is the theoretical understanding of DAGs and topological sort, okay, using depth first traversal. So in the next video, we will code all this in C++ and see how our topological sort looks like. Okay. So I hope you have understood the theory behind topological sort and DAGs. If you have any questions, definitely ask me. I will quickly see in the next video where we will implement all this. Okay. Thank you so much for watching. I will see you in the next one. Cheers.